Welcome to The Nest, everyone, the weekly newsletter for Fisher Flying Products. My name's Dave Hurtner. This week we have had a fun week receiving laser cut component parts and fabricated parts that we are putting into our new Coil Spring Tail unit. This one here is with our lightweight tail wheel that we sell as well, and we will be manufacturing components for our heavier aircraft as well that will made up to the Matco tail wheel. This week we will share some video of the testing of this unit and the changes that we made as a result of the testing. As well, we've got Algy Yates back again for another installment of his Youngster tail kit build. We want to thank Algy for all that he's contributed to this channel. So we hope that you have a great day and enjoy this week's video. This is Fisher Flying Products. I'm Dave Hurtner. Welcome to The Nest. Our video newsletters provide weekly insight into building and flying our 15 wooden aircraft designs. Plini Motori of Italy is a gracious sponsor of our channel. Plini is the manufacturer of the Thor 250 DS. Cozy Carb Ice Prevention Systems is a proud sponsor of this channel as well. Please take the time to watch our videos to the end, as this assists us in the metrics that YouTube uses to rate our channel. Hit the like button if you feel that the content is worthy. We invite you to subscribe to our channel by clicking on the subscribe button and hitting the bell so that you are notified whenever we post our newsletters. I'm going to take you through starting with why we wanted to change the tail wheel on our aircraft. We found that ever since we've purchased the company, we've had issues with, originally they were shipping 2024 aluminum spring landing gear to keep things light, and they were deforming, out of shape, and people had their tail feathers dragging in the ground. We then went to spring steel and found that we had a good supplier for a while, but when we went to go have them made again, that supplier couldn't supply us because they were so busy and we were a small order, and the price was going up and up, and we wanted security of supply and something that was something that we could just put together rather than have manufactured specifically for us, heat treated, and finding the right steel and all of this stuff. So we noticed online that there's been a lot of people doing adventure flying, and there's been a lot of spring type tail wheel brackets that have been made up, and I thought, well, if they can make it, I can make it and design it. And so that's what we did. We went right at it, and we put together a basic design, one where we had a very robust upper bracket that was made out of 3/16 inch steel that was bent down, but it also had a front piece that stayed horizontal, so that it creates kind of a triangle pattern for the mounting bolts and keeps things from being able to twist or to bend sideways. If you're coming in at an odd angle, you're not going to bend this chassis. From there, we decided that we were going to use a bicycle type shock. There's a lot of available on the market, although with COVID it's hard to get them. But we managed to find a supplier and purchased a number of units in the 550 pound per inch and 650 pound per inch ratings, and we decided to go from there and start trialing that. Now, one thing with the design that we did here, we designed it so that we could put 2 tail springs on it to double its capacity for larger aircraft. And so we designed it so that a single will take care of our ultralights, and then a double spring unit will take care of our heavier aircraft. So from there, we designed initially an aluminum main bar with an aluminum foot on it and aluminum brackets for the coilovers. And we got that into testing, and pretty much after the first or second drop, we found that the foot that the tail wheel is attached to was bending upwards, even though it was 1/4 of an inch thick. And that proved to be a problem, because eventually then you run into the shopping cart wheel issue, because the tail post on the tail wheel changes its angle. So from there, we decided that we would get rid of the aluminum square tubing that's an 1/8 wall, and we went with a 16th wall, or 0.58 wall, 1 inch steel tubing that will have lightning holes drilled into the side of it, and with a steel welded foot. And we move the attach brackets outboards just slightly toward the nut, so that it gave it a little bit more strength in its geometry. And so that proved to be the ticket. That true, we've got a unit that all totaled, the lightweight tail wheel and the chassis is right around 4 pounds. And it absorbs a lot of shock. We did testing all the way from an empty test rig that didn't have any weight in the bucket at about 40 pounds, 35 pounds, all the way up to 85 pounds on the bucket, dropping it from a foot off the ground. We did notice that the spring compresses right up, but it takes all the load out of it, and it has a rubber stopper in it that is the ultimate stop for how it ends its movement. But in all of our drops, drop testing, including mounting the whole chassis at a 20-degree angle and dropping it at an angle, we found that we didn't bend a thing, which was great. And the shock worked amicably. I think you can adjust the shock for its sort of initial pre-tension or preload, so that when you get into the airplane, it doesn't sit up, doesn't sit down on the ground. It takes the load with the pilot in it, but yet it still has enough room to be able to take up the shock. So that's how we approached it. We did the drops, and as you've seen through the videos that you've seen while I've been talking, and it's been quite successful. So again, we're going to drill out some lightning holes to try to get it into that 4 pound, our 4 pound goal with the wheel on it. We're also going to be designing another arm that will accept the Matco tail wheel, which we will be using for our larger aircraft. So hope you enjoyed that part. And now on to Algy Yates and his Youngster tail kit. Take it away, Algy.
Hi and welcome to the channel, where I'm building the Fisher Youngster V tail kit. In this video we get the basic rudder completed. The top of the spar is tapered, the bottom of the rudder is closed off, and the important gussets are fitted. I do come across a problem which I'll talk to you about slightly towards the end, and will need to be rectified in a future video. Remember, this is not an instructional video. This is the way I do things, not necessarily the right way of doing things. So if you get any hints and tips, so much the better. Let's get cracking. Okay, since the last episode I've fitted the gussets on the main ribs, and we're now about to do the tapering of the spar. The method I'm using is I've set up this medium density fiberboard MDF 3/4 inch thick, so it doesn't have any flex in it, so it's contacting the edge of the outer hoop and onto the flat section of the rib. It's supported here by another piece to ensure that these are actually flat, and I've set the router up to the depth of this MDF, so I can just run the router down here and it should taper the spar and just about touch the outer edge of the hoop, which has already been tapered slightly by sanding beforehand, so that the boards meet up with it correctly. Okay, so we've got the taper cut with the router. It needs sanding just to finish it off. There's a slight mark here that you might just see. That's less than 1/16 of an inch and will be removed when I cut back for the gusset. So I'm now just going to go and do the other side. I've routed the two areas here on the rudder to take the inset gussets now, and the gussets will fit quite nicely like that. The grain on this gusset is going differently to the other ones on the spar. The two surface sections are going in this direction. That is to tie the front and rear rib together across the spar, and also to allow for the fact that, as you can see, there's a little bit of flex required because of the change in angle from the spar to this upper section of spar. The upper gusset is pretty conventional. You also might see that I've got packing pieces under here and weights on the front rib. Packing piece clamped, and packing piece clamped, and a weight on the spar, and that's to keep the spar dead level as it should be at 90 degrees. The front rib is correct in relationship to the spar, and just to stop any chance of flexing with the trailing edge bow, to maintain everything in its correct position as I put weights on here and get the gusset set. When I turn the rudder over, I'll do exactly the same thing, and that way we'll have it jigged so it is flat. Okay, so not to waste time, while the glue is drying at the far end on the gussets, I think we'll start looking at this taper section. So there's a taper section shown on the plan that goes from the rear of the spar here out to the back edge of this bottom rib. And to do that, it says use 1/4 by 3/4 stock, which we had. So I'm just going to place that on there for the moment, and then just mark a line roughly parallel to the spar to start off with, and I'll cut that. So roughly cut to angle, cut to length. If I put the piece of wood next to this piece of wood just to help support my rule, I can mark in a taper line. So now I'll just sand that on the belt sander. Okay, so as you've seen from the time lapse, I've used the belt sander on my sanding station to taper this. It's we'll need to just address that very slightly to make sure that's a perfect fit. It's tapering down to just about nothing. Once it's glued and cured, I can just feather that last little bit into this section here. This is all glued in, so I'll take the clamps off and I'll just give this a sand just to feather it right down, just to get rid of any of the glue which is in the surrounding area. And then I'll set up the router and just route straight back here so that it's flat, and the routing should then just taper off to the appropriate points ready for the skin to go on. Then we'll turn it over and do the other side. That's been sanded there, so there's no step, and that's been routed so that's flat going back to here. Right, I've routed and dealt with both sides. All the gussets are now done. I just want to do this closing panel, which will fit something like that. I want it to come back to here, be feathered down to virtually nothing. So it's going to have a taper on here. But to cut this to length, just a quick tip on how to do it. I've drawn my line, as you can sort of see there. I'll put the steel rule onto that line. I'll now put my piece of timber onto there, and then with a second steel rule I just lay that on top. So because they're the same size, I can now draw that line, and that line will match exactly where that one is. So now what I'm going to do is I'm just going to cut that, and then I'm going to feather this back the distance from there to there, which I can measure, which effectively is near enough an inch. So I'll just be able to lay that on, mark it and feather it back. Okay, so I feathered it back. You can tell it's 3-ply. We've got our 3 different layers of wood with our dark glue stroke packing bond layer between, and the lines are reasonably straight. They don't have to be perfect, but they're reasonably straight going back to my pencil line here. So hopefully this piece, when I lay it on here, it flex down, there is no real step on that edge at all. So this is effectively ready to go. And off camera I did this particular piece as well, so I can I've got both sides are now done. So what I do is I just put this on here, and so as it goes back in the same spot, I'll put a datum line there and a datum line going across there, so I know I'm going back into the original spot. And then from that I'll clamp it, and we'll draw on the other side. Okay, so just to give you an idea of what I'll be doing, I've clamped the far piece into position, and my normal practice would be to draw around the inside there. That way I now have the area to which I will be applying the resin for when I bond it, and I'll leave this area free for doing it. I'll do that on both pieces. The other side where I've drawn, I will varnish it so that it's ready, so when I bond it into place after varnishing the inside of the box section, it's ready to go, so everything is sealed. So as you can see, I've jigged up the rudder. So as before, weights are on, holding the leading edge flat, so there's no movement, and the trailing edge is all supported at its correct height. And because I did the marking, I knew exactly also where to sand the wood. Now I always sand plywood. I use 60 grit across the grain to create a key, and that's to help the resin penetrate the surface. Plywood doesn't really allow for the resin to penetrate deeply into the surface, and sometimes there's like a slight film on the surface where they put their type of release agent on their moulding when they're actually pressing the plywood. So it's good just to give it a key up with that coarse sandpaper, just to get it to make sure we've got something to glue with. Okay, I'm going to just bond this on, and I'll show you what it looks like afterwards. Okay, all clamped and in position. You might wonder why I have it hanging over the end here and everything else jigged flat. That's so I can get in and make sure I can remove any of the squeeze out, well, to remove the squeeze out which appears inside, so that I can get other components to fit in nice and neatly. And also, we don't really want excess squeeze out showing anywhere. It adds weight and no real strength. The skin's bonded on, and I've gone around with the router just to smooth everything off, all nice and sorted out there. The underside, the other side, I've left open, and this would be the point where normally you would put in your varnish. You varnish this up, you varnish the skin that's inside the skin for that area as we marked on here. Just that little bit there, we would varnish that, and then 2 coats verathane or polyurethane. Once that dries, we would put our resin on. This would then go into position. Once it had cured, according to the plans, we'd cut an oval or elongated hole in here to allow us to put bolts through to bolt the rudder horn on. I'll go into my plans probably in the next rudder video to get around that. I don't like the idea of having a hole cut in here. It reduces the strength, and to access the bolts, if you ever need to take the horn off or to tighten it up, you'd have to cut into the covering, so we'll deal with that. But we have got a problem. Let me show you what the problem is. Okay, so the problem that I've come across, I'm just putting the fin into position here. I was doing that so I could check and the way the shaping was going to be for the leading edge going up the rudder. And if you note that the front edge of the fin doesn't naturally lie with the same front section of the rudder. So my initial thoughts were, I got it wrong. I got the bow wrong. I must have allowed it to flex out. So I double checked the bow here against the plan.
Thanks again for watching. We try hard to bring you interesting content each week. To help us out, please like and share our videos if you feel the content is worthy. To receive the latest info from Fisher Flying Products, click the subscribe button and ring the bell. See you next time in the nest.